Assalamualaikum warahmatullahi wabarakatuh. I am Nur Ardana Amani binti Muhammad Ramzan, and I would like to propose my final year project about antibacterial activity of Morus nigra against Bacillus cereus and Klebsiella pneumoniae. First of all, the idea of this study is to explore the alternative in overcoming the antibiotic resistant issues by using Morus nigra leaves, which appear to have potential in antimicrobial properties due to their bioactive compounds. The main problem driving this study is because Klebsiella pneumoniae and Bacillus cereus are resistant towards most of the common antibiotics, such as penicillin, carbapenems, beta-lactams, and also tetracyclines. According to WHO, antimicrobial resistance could lead to $1 trillion to healthcare costs by 2050. So as bacteria is widespread, so it could affect both global health and also economy issues. The main objective of this research are, first, we are going to test if Morus leaf extracts can stop the growth of these two bacteria. Next, we will determine the smallest amount of Morus leaf extract that can prevent the bacteria from growing, which is known as MIC, and also the smallest amount that can kill the bacteria, which is known as MBC. Finally, we will compare the effectiveness of Morus leaf extracts against gram-positive and also gram-negative bacteria. This study is important because it helps us in finding natural treatments for bacteria that do not respond to common antibiotics. As antibiotic resistance become a bigger problem, it is crucial to find alternatives. Additionally, using natural treatments like Morus nigra leaves support sustainable healthcare as they are eco-friendly and may reduce the reliance on chemical antibiotics. Antimicrobials are substances used to prevent or treat infections. They include antibacterials, antivirals, antifungals, and also antiparasitics, each targeting different organisms. For example, antibacterials for bacteria, antifungals for fungi, antiparasitic for parasites, and antivirals for viruses. So this study of Morus nigra leaves focuses on antibacterial that can kill or stop the bacteria from growing and causing disease. However, some organisms can become resistant to antimicrobials, meaning the treatment are no longer working. In antibacterial cases, it is usually related to antibiotics. In fact, antibiotic resistance can occur naturally as microbes evolve, and also the misuse and overuse of antibiotics can contribute to the problem of antibiotic resistance. The bacteria being tested in this study are Bacillus cereus and Klebsiella pneumoniae, both which cause common infections and are resistant to many antibiotics. When untreated, this infection can lead to serious health issues. For B. cereus, the resistant mechanism is the formation of biofilms, which protects bacteria and helps them stick to surfaces like wounds or medical devices. For K. pneumonia, resistance comes from efflux pumps, which push antibiotics out of the bacteria, preventing them from being killed. Now about the Morus nigra. Morus is the scientific name of the mulberry plant, and nigra is referring to the black color of the fruit. So, Morus nigra is actually the black mulberry plant. Each of the black mulberry plant parts are known for its traditional use. For example, the black mulberry root can be used in Chinese herbal medicine to treat cough, sore throats, and improve blood circulations. They are often made into teas. Next, the leaves are known to help control blood sugar, lower cholesterol, and reduce inflammation. They are usually used in teas, powders, or capsules for people with diabetes or high cholesterol. And the fruits of the black mulberry are used in skin whitening products and to fight infections. They can be eaten directly or used in creams or lotion for skin health, as well as in herbal remedies for their antimicrobial properties. Previous research tested several bacteria, including B. subtilis, S. aureus, E. coli, S. epidermidis, and P. agnes. Different parts of Morus nigra plants, such as the leaves, fruits, and stem bark, were extracted using ethanol. The results showed that some bacteria were susceptible to the extracts with inhibition zones ranging from 15 to 35 mm in the distribution test. Based on the past study on antibacterial activity of Morus nigra, there are no studies that test the antibacterial activity of this plant against Bacillus cereus and Klebsiella pneumoniae. The antibacterial activity of the Morus nigra plant can be influenced by its phytochemicals. The antibacterial properties of the leaves and fruits of Morus nigra have been widely studied. A list of the phytochemicals found in the leaves and fruits of Morus nigra is provided as shown. So based on the past research, the phytochemical content of the leaves and fruits of Morus nigra is similar except for the presence of polyphenols in the fruit extract. The knowledge gap of the study is that there has not been much research on the antibacterial activity of Morus nigra leaves against Bacillus cereus and Klebsiella pneumoniae, even though these bacteria can cause serious infections. While Morus nigra has been tested against other bacteria, but the effects on Bacillus cereus and Klebsiella pneumoniae are still not well understood. And then with the growing problem of antibiotic resistance, it is important to find natural alternatives to traditional antibiotics. Morus nigra is known for its medicinal properties, but its potential to treat these resistant bacteria has not been fully explored. So, this study aims to fill this gap by testing the antibacterial effects of Morus nigra leaves on Bacillus cereus and Klebsiella pneumoniae. This experiment begins with collecting young Morus nigra leaves from Kuala Terengganu due to their high bioactive compound content. Methanol attracts these compounds, which are tested for antibacterial activity using distribution, MIC, and MBC methods. Bacteria are revived, characterized, and tested on MHA. Results will measure the extract's ability to inhibit and kill bacteria, systematically evaluating its antibacterial property. Based on the study, we have three expected outcomes, which is the first one is we expect that the Morus nigra leaves extract have the antibacterial properties. The second one is we expect that the MIC and the MBC value is higher than the previous study due to the use of methanol extractions. And the last one is we expect that the Morus nigra leaf extract can inhibit the growth of both gram-positive and gram-negative bacteria. There are also several limitations in this study, which is the first one is in vitro antibacterial activity does not always translate to in vivo efficacy due to differences in bioavailability, metabolism, and immune interactions in living organisms. Other than that, the study may not identify the specific mechanisms by which Morus nigra exerts its antibacterial effects, limiting its contribution to understanding the interaction between the extract and the bacterial cells. And lastly, identifying and isolating the specific bioactive compounds responsible for antimicrobial activity might be challenging. A lack of detailed phytochemical analysis may limit the study scope. One of the solutions for those limitations and challenges is by conducting multiple trials and also comparing results with the existing research for validation. That is all from me. Thank you.